Hey everybody, it's Bruce and the dog on the floor, and today we're going to talk about OTP. I know you're getting tired of hearing me say it, but OTP is just a library with a common API called a behavior for message passing and managing things like life cycles. And today we're going to focus on that lifecycle piece. So let's get started. So you might have noticed that when I created this application in the first place, I typed a mix, new, brother, as in George Orwell's Big Brother in 1984. And then I had this flag that had all the magic in it. And this is SUP, and all this is the supervisor, and this manages the life cycle. So it starts, stops, and restarts whenever it's required. So that's what we typed to create the project in the first place. This is otherwise an empty project, so let's take a look. Here's the project, and there are two differences that you'll see in this project than you would any other mix project. One of them is that in this application part right here, I have the extra applications like, well, the logger that I'm going to use within the application if things go wrong. And then there's also this brother.application. And that is where we're going to start our supervisor. And the way to read this is that you have the brother application, and then it's going to call the start function and pass this as an initial argument. So if I look in here, you can see that I'm going to pass the arguments in right here. And here I'm ignoring them, so it doesn't really matter what the arguments look like. But take a look. I have the children that this supervisor will manage. And right now there aren't any yet because we haven't coded any yet. This is a template application. But once I do, if I build a gen server, like maybe I have brother.server, and maybe I have some initial argument, that's what it's going to look like. And all that means is that I would call the start link on brother.server, and I would pass the hello world as the initial argument. And so one of the things I want you to pay attention to is the number of times that we see words that have to do with lifecycle. There's the start. There's the children. There's a strategy, but this is a strategy for how we start and restart things. And then there's a start link with the children again. So this is all about starting the application. And how does Elixir know to start this project where it doesn't start others? Well, we're going to take a look at that next. Now, we want to bring up some code, but in order to bring up the code, you have to know a little bit about how this application works. So whenever an Elixir application is built, it's actually built into a directory called _build. So I'm going to look at a file that's in that directory. So notice we have this build, and there's a directory underneath. Well, this is the environment. And you might have a test environment, you might have production environments, but we've by default, when we entered IEX in the previous episode, we entered that environment which had to be built, and that was the dev environment. And so underneath that, we have the lib directory for the brother application. And look, there are two different directories underneath. I'm going to look at the ebin because that's where the production executable code is going to go. Now I'm going to look in here, and there are two compiled files, application.beam, the brother.beam, and you might recognize these as the two modules that I created. But there's this third piece, the brother.app, and this has some Erlang configuration code. Yes, it's Erlang configuration code. So if I take a look at this, and you can see Erlang leaking through. You can see everywhere that you have a comma. Well, this is a terminator, and there are terminators between every Erlang statement. You can also see that the atoms that represent module names are expressed in this way with a lowercase character instead of an uppercase character. And then one of the things that you could see is that these are the modules. And this is the starting specification for the supervisor for the application. The module is elixir.brother.application. It's going to call the start, and it's going to pass these arguments for the arg. And that's pretty cool. So what that's going to tell us is that when we start Elixir, it's going to start this supervisor. And we're going to take a look at what that supervisor looks like next. So what we're going to do is start up IEX, and what's going to happen is based on that configuration file, it's going to start this module. And we don't care what the arguments are. And it's going to start no children, but it will have a supervisor. And it's going to call the supervisor brother.supervisor. And this is not a module with some code. This is just an atom. But let's make a shorter one called supervisor. And that supervisor is going to be the name of the registered gen server within the system. So I'm going to save this much. We're going to go over here. We're going to start IEX. Then I should be able to feed that into gen server.where is, and I get a process ID there. And I can already tell that that's alive, right? And we can interact with that supervisor. I could say supervisor. Let's take a look at the children. Which children? And I'm going to pass sub. And it doesn't have any children because we haven't started any yet. And we can change that. That's going to be easy to do, but we need to code the supervisor itself. We'll code a really skinny one with nothing more than an init just to kind of see how this develops. So I'm going to exit this because, well, we need to, if we make some compile changes, in order to have that supervisor kick in, we're going to have to enter IEX again or call the function ourselves, which I really don't want to do. So we're going to go into here, and the brother itself, this is where we're going to have our gen server implementation. And so I'm going to say use gen server. Then I'm going to say def start link, and this is going to have some initial argument. And then I'm going to say gen server dot start link. And then I have to tell it where the code is that we're implementing, and that is in this module right here. And the syntax highlighting gives me a nice clue that I'm on the right track. And then I specify the initial argument, which is this one right here. And I'm going to give this a name of Big Brother. Or how about just big? I don't really want to type a lot. And then, so this is the client API. And so the callback that's associated with that is nothing more than an init. So I'm going to say def init, and this is going to take an initial arg. And all I'm going to do is pass that right on through. Like that. So I should have a working gen server, and I ought to be able to plug that in right here. And where is my gen server implemented? Is it implemented there? No, it's implemented there, right? So let's go back into brother. The start link is whatever argument that we pass through. So let's have some character in the big brother. Let's call it maybe Julia. And she liked real coffee. Okay, so we'll go ahead and start Julia that way. And all this is the module that has the gen server, And it's going to call start link with this argument. And if we want to, we could put brackets around that, but we don't have to. So I'm going to do it this way. And that gives me the 2-tuple with a atom and another 2-tuple. No, it's not confusing at all. Okay, so we can go ahead and start this by saying ix mix. Oh, by the way, let's go ahead and drop something in our init just so that we could know this is up. Okay, and so now when I go back over here, I could do IEXS mix. Code block contains unused literal starting. Okay, I see. So io.puts like that. Okay, let's try that one more time. Okay, so this is starting up, which means that's our worker. So that means our supervisor is also starting up, but we don't have to take a word on that. We could take a look at it. We could say process, or we could say sup gen server dot where is. So that looks like it's up and running. And so I should be able to do supervisor which children on sup. Okay, and now we can see that there is a child tuple in here. And we could make sure that we have the right tuple right there. So what do we call that? We called that big, right? So then we could do a gen server where is. Beautiful. So this is 163, and that's the same PID that we see right there. So this is the module with the implementation. There's the PID. It's a worker, and we have a list of implementations for code swapping if we're doing that kind of thing. So what we have here is a great way to auto start the various components as they come up. And one of the things that I can do is kill my process. So I could say process.kill. How about exit? And then we have this PID right here, which is V3. That's IEX line 3. That's all this V3 does. And then, so I need to tell it why. Big Brother is watching. I don't know, it sounded good at the time. Okay, so you already have a hint to what's happening, that we've started another process, but while we're at it, why don't we take a look at my supervisor's children, right? So I'll just use my history. And now you can see that there's another Big Brother, which has started. It has that PID. And by the way, we can also take a look at this PID, which is V3. That gives me the old PID, and I can see if that's alive. No, that's not alive. But what's happened? I have another instance of Big that's been registered again by the machinery. So Big has already moved on to something bigger and better, pun intended. And what we have here is pretty significant improvements in our reliability, because if one of our services happens to die, there's a supervisor that has our back and can bring the other parts of the system down that have dependencies on it and bring this back up. And so what you have is the IT crowd's tagline, "Did you try turning it off and on again?" implemented in software that gives a stunning reliability, almost a self-healing property, and that, my friends, is an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.